So the question is detect cycle and directed graph. Okay. Now let's read the problem statement first. Now we are given a directed graph with vertices v numbered from 0 to v minus 1, edges e. Check whether it contains a cycle or not. Okay, so we need to find a cycle in a directed graph basically. So here it is a cycle in this graph, that is from 3 to 3 itself, and in this graph where we don't have any cycle, that is we are simply going from 0 to 1, 1 to 2, and from 2 to nowhere. So basically this graph does not contain any cycles. Okay, now let's try the solution, writing the solution for this. Now I am taking this graph as an example, that is from 1 to 10, and we have it seems like a cycle, but it is not a cycle because it is a different path, this to this, 1 2 3 4 5 step 5 and 6, and 1 2 3 7 5 6. This is a different path. Yeah, so basically it seems like a cycle, but actually it is two different paths. But here it is 8 9 and 10 is definitely a cycle because we are going from 8 to 9, 9 to 10, 10 to 8. Okay, so this is our adjacency list for the following graph. And for the solution, actually we will be needing two arrays. First one, we will call it as a visited array, and second we will call it path visited array. I will tell why this is path visited array, and so I will be using a DFS for solving this question, DFS. Initially what I will do, I will call for DFS of 1 basically, so I will mark it as 1, and also it's path visited. Now I will move to DFS of 2 because from the adjacency list or from the graph, DFS of 2, and mark it as 1, mark it as 1. Okay, now 2 is also visited. Now we will go from 2 then to 3. Now I will call DFS of 3, that is 3. Now from 3 we have two different paths, that is either from either to 7 and either to 4. So according to the adjacency list we will move to 4, and I will mark it as dotted because we will return to this path later actually. So DFS of 4 basically I'm calling. So and 3 is already visited actually, so now 4 and 4. Now 4 we are actually going to 5. Okay, so DFS of 5, then I have to mark it as visited every time I'm going in any path 5. Then from 5 I will go to here 6. So basically DFS of 6 I will call, and I will mark it as visited. So actually we end our path here. Okay, from this is a one single path, 1 2 3 4 5 and 6. Now for we can see in the adjacent field there is no further path, so we will stop here and we will try to return back. Now what I will do here, when I am returning back from a path, I will mark it path visited again to be 0. So when I will move from DFF 6 to DFS 5, I will mark 6 as 0 and path visited array. So okay, now when I will move from DFS 5 to DFS 4, I will mark it as 0 here to here, then here to here. Now I will mark it as 0. Now from 3 here, we have another call to make, that is to DFS of 7, that is this call. But when we will go to this call, DFS of 7, its adjacency list has 5 in it, but 5 is visited and its path visited is 0, means we have visited this node but through different path, not through cycle but through different path actually. So we will return back from here, and we will turn back to DFS of 2 by marking it as 0 and 0 and again to 1 at 0. Okay, now this call will be over, so we will be calling a DFS for every node as we already know. So we will calling to DFS of 8. Okay, now I will mark it as visited. Actually this call will be made. Okay, okay, so DFS of 8 will be 1 and its path visited is 1. Okay, so now in the adjacency list of 8 we have 2 and 8. So basically to call DFS of 2, it is visited and path visited is 0. Basically it is visited, path visited is 0 but through different paths. So we will return back from here. Now we will go to DFS of 9, basically DFS of 9, and I will mark it as 1 and 1, that is visited, path visited. Now from 9 I will go to 10, that is DFS of 10. Okay, that is from here to here and from here to here. Okay, now from DFS of 10 I will go to DFS of 8 again. Okay, I mark it as 1. When I will go to DFS of 8, okay, so when I will go to DFS of 8 here, I will check that it is visited. This node is visited actually, and its path visited is also 1, which eventually means that I am visiting this node in the same path I am traversing. Okay, so I will return true from here. Okay, the key, which means I have detected a cycle and I will return true, and eventually our main will get true as the answer. So we can say that we have detected a cycle in our directed graph and can return the answer. Okay, now let's discuss about its time complexity. So as I can see that we are visiting each and every node in some of the calls. So we can say that it is a general DFS call. So general DFS time complexity is nothing but a V plus E, and space complexity will be nothing but O plus OV actually. OV because we are using a separate array, that is visited array and path visited array. Okay, I think that's all here. The time complexity is done, space complexity is done. Now let's code it. Okay, solution. Now I will code the solution for this question. As we have used two arrays, so first I will declare these two arrays and then try to move to the further solution. So vector int visited of size v with the initial value of 0, then vector of int path visited of size v with initial value of 0. Now what I will do, I will call for every node that is less than v I plus plus, if that is not visited actually, then I will go and call DFS for it, that is from I visited, path visited, and our adjacency list. Okay, so now instead of going back from here, what I will do, I will enclose this in if condition, that is if this is true in any case, then I can return true eventually. Okay, and if I came out of this for loop, I can return false. Okay, now let's code the void DFS part actually. Void DFS int node and other is the vector. I will take it by reference because in DFS calls we will be needing this. Now I will be using int path visited, okay, by reference to actually vector. Then I will be making my adjacency list. Okay, now what I have done in the algorithm, as soon as I'm visiting some node, I'm marking its visited and path visited as visited. Okay, so let's do it. So visited of node is equals to 1 and path visited of node is also equals to 1. Okay, now what I'm doing, I'm moving to its neighbor, that is for I will be using for loop here, that is okay, auto, sorry, auto I adjacency list of a node. So if this node is not visited, the batch which is I, then I can call for DFS. Okay, else if we will have another case, that is of its path visited. Else if its path visited of node, not node actually, of I actually is equals to 1, means it is visited, so I can safely return true from here. That is this is the condition, that if in both the case like this 8, both visited and path visited is 1, so I can return true eventually, है ना? Okay, now I will call DFS, actually yes, DFS for I visited, path visited, and adjacency list. Now catch is something like this. Now here the catch that I have to enclose this in if else, if condition basically, and if this is true, then I can return true from here, and no need to check for any other node beyond this, because we have found a single cycle, because we don't have to count the cycle, we have to just find the cycle actually, and return true, return true. Now when we are going back, I have to mark that node as unvisited in path only. So what I will do, I will use path visited array, path visited of node equals to 0. When going back from this DFS, and I will return false because we have not found any of the code. I think the code is complete. Let's try to compile it. Let's see if check if it's giving any error or not. Okay, it is giving error. Okay, could not convert solution. I think I've done something wrong here. I don't find. I need to debug this code actually. Okay, I have used actually bool. It should be bool, not void. Basic DFS. Okay, yeah, it's giving the true answer. Okay, now let's try to submit this for all 410 cases, and it actually passed all the test cases. And I think it's the time complexity is good. That's why it passed all the test cases. I think so. Okay, thank you.